is something like nanobio. This is the very important keyword for this subject. So we can use some inorganic nanomaterials like different kind of like metal nanoparticles, like gold nanoparticles, platinum nanoparticles, silver nanoparticles. Also some non-metal like carbon nanoparticles, like carbon nanotubes, graphene. So this is this kind of bio means antibody, different kind of DNA, RNA, aptamer. So this kind of things also very nano size biomolecules also we'll use for fabrications of sensor device. So you can see here one sensor device like this. You can see my cursor, right? Guys, can you see my cursor?
Yes, sir. Yes, sir.
Okay, but I will use also. I have some touch pen, so I will use that one also for put some different color. So here you can see just when you drop the samples of blood, so it will come through some different kind of membrane. Then finally it will come to the sensor surface, and if the sample contains something like disease marker like cancer, like dengue, malaria, different disease marker it can be. When it will come to the surface, then it will bind to the sensor surface. Then we'll get the output. So this is kind of the fundamental things of the biosensor. I will come the definitions of the biosensor slowly. So first things I want to show you here, the why this subject is so important. So these things are very familiar to all of you, right? Health is wealth, right? So without healthy life, we cannot enjoy our wealth, we cannot enjoy our day-to-day life, right? So health is very, very important. And this term is we know from our childhood. Right, guys? Do you know this one, right? Health is wealth, this term is very familiar. So what we should do? We should diagnose ourselves regularly. This is the one best thing. Like say, if you have any disease, if you can diagnose at the early stage, we can save our life, and we can save the patient life. Like cancer, see, if somebody has any cancer, and if he or she not diagnosed properly, regularly, and suddenly doctor find that you have cancer in the metastable stage, then what happens? We cannot save their life because although we have so many medicines, so many therapeutic methods, so maybe we can go for different kind of therapy, but it is very difficult at the metastable stage or the final stage to save the patient life. So what we can do, if we go for the diagnosis for proper way, if we can detect the disease at the early stage, then only we can save the patient life. And doctor can guarantee you that yeah, you can live a healthy life if we can detect the disease at the early stage. And for the detections of the disease at the early stage, we need some technique. And what is the technique? That technique called that biosensor technique. Some device we can develop. That device can help you to detect the disease at the early stage. So how we can develop, how we can design that device, right? That I will teach you. So here is the motivations of this subject. Guys, so are you getting the motivation, right? So what I am saying, why this subject is important. So the first motivation is that you can see worldwide there is so many diseases like malaria, tuberculosis, HIV, and 60% worldwide people are suffering different kinds of chronic disease, and almost 50% worldwide people suffering like diabetes, like different kind of obesity, diabetes. This is also very common problem nowadays. And cardiovascular disease all over India, not only the world, all over India, you can see all maximum states they have this problem. Almost within 39 seconds, someone dies from the heart disease. So it is very, very important to detect this disease at the early stage. That's why to save the patient life. What is the solution? The first solution, generally people what doctors also suggesting to give the sample, that's like the blood sample. Hello.
Sir, can you make the slideshow on full screen, sir? Sir, I cannot see,
Oh,
sir,
it is.
properly.
Oh, it is like small screen, right? Okay, wait,
Yes,
wait.
sir.
That is problematic for.
Yeah, yeah. Because it is now double, like one slide and very small, right? Okay. Just wait. Is it fine now?
Yes, sir.
Yes, sir.
Yes, sir.
Fine.
It's okay, good. Yeah, if you face anything problem, just let me know. I will try to solve it. Okay, good. Okay, so what's the problem now? So if you want to detect the disease, the list, detect the disease. So what the doctor suggesting? So just you have to give the sample. Then we have to pre-processing we need, right, for this blood sample. You know, you already have to explain this thing. So that's a very common way I'm going to teach you. So you have to give the blood samples, then they will go for some pre-processing. They will send to the hospitals, or not only hospital, that they will send past the diagnostic center. Then very many we need so many big instrument, very powerful instrument to detect, to scan the not only one analyte, so many analytes we want to detect, right? So we need very powerful instrument, the very bulky instrument, and for that instruments actually we need some very trained personnel. So common people they cannot handle this kind of big instrument. And for handling this kind of the instrument is very laborious, time consuming, expensive, and complex because we need many multi-step processing. And this kind of analysis is lacks of miniaturizations. So if we think about the point of care, so this kind of device should be very small. So that we can drop the sample and we can detect the disease if it can come very close to the patient, right? Like the glucometer nowadays available, I think you already have seen, like the glucometer. So patient can detect by themselves, right? They can just prick the finger, drop the blood, and they can see. So something like this device should be available for all kind of the disease, like cancer, all the disease. So this course will teach you how we can develop this kind of very small device, very simple device, layman can use. Very no need for any extra training for this. Okay, the solution for this problem is the biosensor. This is the one kind of solution. Let's come to the definition of the biosensor. So biosensors, it is kind of a analytical device. Just try to understand the definition of the biosensor. So biosensor is kind of the analytical device with one or more biology recognition elements. What is the biology recognition element? Biological recognition element is the bioreceptor that can, the disease marker can bind with that receptor. That is the biology recognition element. So it can be antibody, it can be peptide, it can be aptamer, it can be enzyme, DNA, RNA, something like this. So bioreceptor, so biological recognition element, nothing but a bioreceptor. So bioreceptor is kind of the biomolecules that can bind with the biomarker. So now the question, what is the biomarker? Biomarker means that is a disease like protein, like if you have the malaria, then malaria protein we can detect with the help of bioreceptor like some antibody. So biomarker nothing but the target, that is the disease target, that is called the biomarker. So that biomarker we can detect by the help of some bioreceptor. So bioreceptor can be immobilized on the sensor surface. So here we are saying transducer. So transducer nothing but a sensor surface where we can immobilize our bioreceptor. So biosensor, what is the definition of the biosensor? It is just a analytical device that can detect the disease with the help of some receptor. Clear, students? Is it okay? Then I can go to the next step. Just understand first few
Sir,
classes. You have to understand each point.
sir, this analyte is some kind of virus or this is some kind of microorganism like
Yeah.
disease
Yeah,
causing
I will.
microorganism.
I will come each point, each keyword I will show you here. Analyte means just the target, like the biomarker. That is called the analyte. See, that analyte is bind to the bioreceptor, like antibody. So bioreceptor, just for example, it is the antibody, is the bioreceptor. So analyte is the like some disease marker. That is called analyte.
Okay, so so it is not the exact virus, sir.
No, it can be virus. It can be virus. It can be virus. It can be bacteria.
Okay,
Anything.
so it can like anything like okay, sir.
Anything.
So and this bioreceptor, if it analyte is a virus, then bioreceptor is going to be and this some kind of antibody.
Right. So virus selective antibody. So you have to say it should be selective. At that point I will come. So biosensor will be very selective. So if I develop a biosensor for like virus, so it should detect some specific virus like SARS-CoV-2 for COVID-19. So if I want to detect the SARS-CoV-2 for COVID-19, so I will immobilize a bioreceptor that will be very specific for SARS-CoV-2, not for any other virus. So if it is selective for other virus also, then everything will bind, right? You cannot find or you cannot predict if you are getting some signal for your SARS-CoV or for anything else. Clear? So that bioreceptor should be very specific. That's why in the biosensor. You understand the specific term?
Sir, sir, that means we will make the bioreceptors.
No,
Okay, we will
maybe we
artificially
can
make.
synthesize or time. See, the bioreceptor is antibody, right? So in our body,
Yes.
antibody, we can make some animal model, like in a mouse or in some like somewhere. So in any animal model, we can produce the antibody and we can separate them from that animal model.
Okay.
So you also have antibody. Maybe we can collect
Sir,
some sample from body.
sir, there like for HIV, this HIV virus, so there can be some antibodies for the HIV also, because like if we have antibodies for HIV, then why we are like why people are dying from HIV, sir?
See, we already we know the HIV virus, right? We can put that virus to some animal model, then we can produce some antibody in the animal model, right? Now, so that's why this is the actual vaccine model. We are developing people like the SARS-CoV, the vaccine, the people how they are developing. See something like this way, but see, as there will be so many side effects, so sometimes we are thinking that this antibody can be good and that can be okay for the HIV precaution. For elimination of this disease. But sometimes that method may not be feasible for the human case, may not be feasible for man-to-man case. So that's why we need the clinical trial, and we are waiting for a long time for the clinical trial for developing a vaccine. It is very simple. We can think about the vaccine development is very easy, but it is not so easy. We need the clinical trial. There is so many side effects there. It may not be feasible for whatever we are developing in the animal. So first, definitely we are not developing at the beginning in the human body. We are developing at first in the animal model, right? So then we have to pass through so many steps. Clear, guys?
Yes, sir. Please.
Yes, sir.
Okay, so let's go to the next term. So I will show you so many keyword. Yeah, first few classes I will go very slowly because I will show you so many new terms. So let's clarify this all the terms. Let's understand all the terms. Then I will show you many applications. Then you can think about how we can develop a device. Let's go one by one. So here antibody, peptide, aptamer, enzyme, DNA, RNA, everything they are the bioreceptor, right? So they can bind with some specific analyte. That is the biomarker or target. Clear? So sample. So here you can see in the sample there is so many. I put different symbol. I mean your sample may contain your target analyte, also some other analyte, right? So if you collect a drop of blood, maybe somebody have the malaria, maybe they have also the dengue, also at the same time they have the cancer. But you want to detect the only cancer, not malaria, not dengue. So malaria and dengue should not interfere, right? They should not interfere with the cancer because you are going to detect cancer. So in the transducer nothing but a sensor surface where you are immobilizing your bioreceptor and you will apply some potential. Potential means some applied voltage, something you will apply. Then you will get some output signal, like in the form of current, in the form of charge, something like this. That is output. The input, some potential applications on transducer, that is the surface, and output you will get in the form of current. Like if you have the very high concentration analyte, so you will get high current. If you have low concentration analyte, you will get the low current. And from the amount of current, you can predict how much biomarker present in the sample. Right? It is very common things, right? Clear, students?
Yes, sir.
Yes, sir.
Okay. So let's come now technique. As I said you that on the transducer, I am going to immobilize some bioreceptor. Now analyte will bind with the bioreceptor and will apply some input, will get some output. So depend on your input or output, so we can give some nomenclature of the biosensor. So what's the nomenclature? It can be the electrochemical. So electrochemical means you will put some electrical form of some input, like potential, getting some output like current. So this is the electrical. So it is called the electrochemical biosensor. Another is the colorimetric. So what is the colorimetric biosensor? Colorimetric means you will see the change of the color of the sensor surface. So like if your sample does not contain any biomarker, then you will not get any color. You will not can find any color change. But if you have some biomarker present in your sample, then you will get some color change. That is called colorimetric biosensor. Now the mass biosensor. So mass, from the term of mass, you can see that change of mass. So from the change of mass, we can predict how much analyte present. That is called mass biosensor. Thermometric is the change of the temperature. Then we can predict. But from there's in the market, there is so many technique available. Among them, in this course also, I'm trying to focus some very simple technique. Because if we cover all the technique, it is very difficult to cover within this semester everything. Right? We cannot cover everything. So I will focus on one very important technique, like electrochemical technique. So why I will focus electrochemical technique then? Because electrochemical sensor is very simple technique. And by using this electrochemical technique, we can easily develop a sensor device that can be useful for point of care. So that from the beginning, I am saying our course name is the point of care biosensor. So that's why electrochemical technique I am trying to focus on. And electrochemical technique is very sensitive than any other method. So why we need sensitive method? Because we want to develop a sensor that can detect the disease at the early stage. That is our main goal. As from the beginning, I am saying, if we can detect the disease at the early stage, in the many disease case, then only we can save the patient life. At the metastable or end stage, if we detect the disease, then no use. And easy to miniaturize. So something we have to develop so that we can bring the device near to the patient. That is called bench to bedside. Whatever we are trying to develop, bench means the laboratory. bedside means near patient. So if you can easily miniaturize, if you can develop something very small, then only it is possible to bring them to near the patient, or people can use them day-to-day life, right? Layman they can use only if it is develop some very small device, not the bulky instrument like this. And this last point is very important, the affordable. So sometimes we are developing so many technique, but because of the expensive technique, we cannot commercialize them. Sometimes we cannot commercialize them for the common people, especially for the developing countries. Just think about in the rural area, people they cannot, if they cannot afford. So there is so many diseases like tuberculosis. So there's spreading very bad way. But if you can detect if you can develop a very small device, very simple device, and they can detect, this affected by the tuberculosis, then only we can go for some disease, some treatment, and we can save the patient life. Tuberculosis is a very dangerous disease. So if somebody affected by tuberculosis, he means some he will spread the tuberculosis. There is so many stages there, but if he affected by the last stage tuberculosis, he or she will spread that last stage disease. It is very dangerous. But if we can detect that, he or she is affected by tuberculosis, then let's send him for the diagnosis. So like the same thing for the COVID case. If we have some very simple device in our home, and we can say that, he or she is affected by COVID, so let's keep him for quarantine for the until he or she will be fine. So that's why these 4 important point we should remember for developing a sensor device for point of care. Clear? Any questions, students?
Yes, sir, clear.
Sir, accuracy should be also be it should be also accurate, na sir?
That is the you are entering is a very inside of the device. That will come later. I will come slowly. That accuracy, this thing I will describe when I will come to the design. And that is, you are true. It is very, very important. But first we have to think about these things. If it is okay, then we have to go for accuracy. And without accuracy means if it is not accurate much, if it is not 95%, 95%, if it is the less than 50%, then it is very difficult for commercialization, right? Or difficult to bring for the actual disease diagnosis, right? That point will come later. That I will describe.
Sir, why does it have to be simple? As long as it's easy to miniaturize and affordable, it's fine, right? Why should it be simple?
Why it should be simple? Just think about what is the meaning of the simplicity. So see, I am developing a sensor device. Okay, there is lots of channel there, lots of electrical connection we need, lots of chemical we need. So we have to put so many chemical. So for that, maybe someone should drop the sample one point. Another point we have to inject some chemical. Another point we have to push something bottom so that all the chemicals should come and mix together. So sometimes we are developing some sensor device for, the miniature sensor device we are developing. But because of so many steps, so layman they cannot handle. So something we need the device just drop and wait for few minutes. I want to see the digital value. That is called the simplicity. But if they want to do some steps like drop, inject some liquid, push some button so that they will come to mix together, then do some another step. I'm saying about that. So if it is not that, then layman cannot use. Understand?
Yes, sir.
So we want to develop something like glucometer. Glucometer is the example of the very simple biosensor.
Sir, what is the role of the how are the transducers selected? What is the preferential method by which we can say what transducer can be applied to specific cases?
Yeah, that's good questions. What's your name? I cannot see actually.
Sir, Shomo.
Shomo. Okay, good.
Yes.
See, Shomo. So how we are selecting the sensor, that depends on the many steps. So first steps will be that selection of transducer. So which transducer you will select, that depends on which technique you are going to use. So suppose you are going to use the electrochemical technique. So you have to then think about some solid, maybe some solid sensor surface. So that solid sensor surface, maybe you can think about some gold plate. Maybe you can think about some carbon surface. Maybe you can think about some glass surface. And on that surface, maybe you can immobilize bioreceptor like antibody. Now, that actually this is very, details way I will teach you next few classes. That selection of transducer is very, very important. So first of all, you have to think about if we select a gold, like gold sensor surface, so it should generate low background, not high background. Maybe we can think about some carbon-based surface. So if carbon-based surface generate low background instead of the gold surface, then we can choose the carbon, not the gold. But if you are getting signal to background ratio very high in the gold surface, but you are getting low signal to background ratio in the carbon surface, then definitely you have to choose the gold. Yeah, that what is the signal, what is the background, what is the signal to background ratio. So then you should know first this all the topic, right? So
Yes, sir. Yes, sir.
so these things I will cover step by step. Then only you can understand how you will choose the.
Okay. Okay.
But this is a very good question. Keep asking the questions. But if because today is the first class I am teaching, right? Very beginning.
Yes, sir. Yes.
So I will cover one by one. So if it is not the right time, I will say, maybe after 15 minutes, I will give you the details idea. Okay.
Hello, sir.
Yeah, tell me.
Sir, can we use any kind of biosensor for any type of analyte and bioreceptors? Like is it like this that this analyte and bioreceptor should release some kind of like charge or electrons basically for it to be used on an electrochemical biosensor, sir? Like,
Good. What is your name?
sir, Sarfaraz, sir.
Surprise. Good. Yeah, you are actually very much. I'm saying your curiosity. I respect your curiosity. It's very good because yeah, you understand how you are doing right. But you are also same. You are thinking from the beginning very good way. But just wait for a few more classes. Huh? You will get all the idea. Okay. See, everything. It is very true that, and I can say definitely. Your answer, my answer will be definitely and yes. You can detect any kind of the disease by helping of biosensor device. But how? That is our challenge. So how we can develop a sensor device for any kind of disease detection. So I will teach you few classes for how you can develop a generic sensor, not for a particular sensor. So this actually will help you for detect any kind of the disease. I mean, like this simple generic sensor I will develop, like antibody, antigen. Like this way I will teach you. So what you will do? You will change the antibody, you will change the biomarker, and you will get some sensor device for any kind of disease. Okay, Sarfaraz.
Sure, sir. Yeah.
Good. Okay. See, now we are going to develop something, some sensor device that easily we can integrate with our mobile device like smartphone. You know why smartphone? Because nowadays, I think everybody, not I can't say 100%, almost maximum we are using the smartphone, right? Now, if we can if we can develop some very simple, very small device and readily we can inject where we are plugging our charger, right? Charger point in the in our to our smartphone. Actually, we can develop some very small chip that is actually biosensor chip. That chip we can inject to that charger point, that charging point, so that sensor will be connected to your smartphone. Now we can develop something app like this. We can develop some app. So this app can control it can control your sensor chip. Now we can apply some potential by using this app. So we can, I mean, inbuilt in the smartphone, we can we can keep some electronic component so that they will also connect with your sensor chip. So some potential can be applied, and we'll get some form of like this, some signal, some kind of this kind of shape signal we will get, and that can be visible in a smartphone. And because of artificial intelligence, if we can use, so we can actually get some output digital value also. And how, if we get this kind of the signal, so it corresponds to maybe like 10 nanogram per ml of biomarker concentration in the sample. So like this way, we can get some digital value. So by using the smartphone, so that's why local reagents, specialized equipment don't need. So everything will be there on the chip, and we can integrate with the smartphone. And we can detect not only one disease, maybe we can detect multiple disease marker at the same time. So on the sensor chip, maybe we can immobilize many antibodies. As I am saying always, the specific antibodies maybe we can immobilize. Like if we immobilize like malaria and one side, and we can immobilize the dengue. So at the same time, we can detect the malaria and dengue also. That is called multiplex detection. Right? Clear, guys? So like this way, we can develop some simple device and also some wearable device. Like some in a scheme, we can print some biosensor on the screen. So this biosensor, what it can do, it can it can absorb like some analyte from your like you can say sweat or interstitial fluid. Then if you have some critical or dangerous stage, then it will send some signal wirelessly, and that signal can be transferred to like by using your cloud or database. So we can send this signal to your doctors also. The doctor also can be notified that the patient is in the dangerous stage. So something like this also we can think about, so advanced stage, by using the Internet of IoT, Internet of Things, and every means. And I said there is, in this class there's so many electronic people. I mean, from the electrical engineering background also there. You can think about some development, some electrical component, electrical circuit, by using some IoT and using just cloud, everything. You can store the data, and you can transfer the data from the biosensor surface to the cloud, then send to the via Bluetooth. You can send to the doctors or send to some mobile or local sub device. They can get the notification. So something like this. So you can think about some very modern technique you can use here also. Clear, guys? Hello, students?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
Yes, sir.
Is this interesting? Can I motivate you?
Yes, sir.
Yes, sir.
Okay. See, this is our main driving force for this course. Bring the rapid test method, convenient and immediate proximity to the patient. Okay. So how we can bring the rapid test method? So it should be close to the patient. Okay. So now I will show you a very interesting video, and this video will tell you what is the meaning of this sensor device by using a very simple device like glucometer. As I'm saying repeatedly, I think many of you know the glucometer, right, guys? Do you know the glucometer?
Yes, sir.
Okay, so glucometer, this is a biosensor device. Let's see this video and enjoy this video. Let's see. Is it audible, guys?
No, sir. It's not audible.
Sound is audible,
No,
right?
sir. No, sir.
No, I just turned off. Audible, right?
No, sir.
Not.
No, sir. Not audible.
Mm,
Sir, you have to share the sound of the device with us.
right. You're right. Some of the sound is not there. Maybe that's right.
Or you can share the link with us, sir. We'll see in YouTube.
Wait. I think it was already shared, but let's see again. It's not audible? No.
No, sir.
Hello?
Sir,
Yeah, somewhat
Your
audible.
voice is very faint, sir.
Audible? No?
It's very faint,
sir,
sir.
on the subtitles, sir, it will be useful.
Is it audible? No.
Not audible, sir, but on the subtitles, it will be
Okay,
useful.
okay. Please see.
Very faint sound is coming. Not audible, sir.
Sir, we can't see the captions, subtitles also, sir. Sir, you can share the link with us, sir.
Sir, can you
Yes.
share the link in the chat box, sir? We'll watch it.
Yes.
So very faint sound.
Maybe I have to share the sound. I have to find out the sound option. Maybe somehow the sound option is off now, right? So I'm sharing the link. You can see this one. Okay, please, you can check this one later. So this is kind of things. See, the sound option should be here. Wait.
Sir, are you using a microphone for the sound thing or a headphone which is plugged to
No,
the? Oh, okay.
no, I'm not using microphone.
Sir, sir, you will get the sound option in the when you are sharing the screen.
Yeah. I that's why I'm just trying to share again.
Yeah,
Here
and
actually,
then you will get the option to enable the computer sound.
I am sharing. It is your entire screen, and then here actually I saw last time. Let's check. Anyway, I'll do it in the next class also again. I will find out. So let's continue the class. Okay. So this is the that's why biosensor. So biosensor actually it is the beginning of life. That's why I said this sentence. It is the beginning of life. I mean, so at the very early stage we can detect the disease and we can predict. We can make some plan. We can go for diagnosis and we can save the patient life at the early stage by using the detection of disease early stage. See, so some kind of biosensor we can print on the screen also. You can see here. On the screen also by using some conducting polymer or by using some conducting material, we can print and we can fabricate some biomolecules on the surface and it can detect the many kind of analyte from the sweat sample, from interstitial fluid sample, they can detect. Like a pregnancy kit meter available in the market right now, you know this one, pregnancy kit meter or glucometer. These two biosensor device is very familiar nowadays and very good, and it is commercialized in the market. It is available, and they are very cheap. So this kind of sensor device, actually, we also want to develop similar like very simple device. So the mechanism of the pregnancy kit and the mechanism of the glucometer, they're very simple. Just drop the sample and we can wait for a few minutes or also few seconds, and we can see the digital value, or we can see the color change. We can see the result. So something like this. So here actually you can see like a sensor chip of the glucometer. So here one area that is called the working electrode, another area that is called the counter electrode, and another is the reference electrode. So the three electrode system combined together, and it forms a sensor chip. So this working electrode, what is the working electrode? In the working area, actually we are immobilizing many bioreagent. So if you have the glucose in the sample, then it will come to this working area. They will react with some reagent that is called the glucose oxidase, that will be on the sensor surface. So glucose will react with the glucose oxidase, and during that reaction, we can generate some electron during this reaction. It's kind of the chemical reaction. So that chemical reaction will produce an electron, and that electron we can transfer. We can measure by using this electronic device. So if number of the electron high, so we'll get the higher current. Means if the concentration of glucose is high, then it will react with the glucose oxidase and it will generate more electron, and more electron means more current, and we will see the higher signal. So if your sample contain less glucose concentration, I mean it will produce the lower number of the electron, you will get the lower current. So then what we will use some app. So that app actually work in this case. So there is some artificial intelligence we will use, so that it will work on that number of the electron. It will transfer this one to the digital value. That digital value we can see. Okay. See here. This is the very important area we are learning. Biosensor. And worldwide, people are very much interested in this area. Why? See, if we can develop something like this device, then we can solve many problems. So that's why worldwide, people we have very big business market in this biosensor. Million US dollars they are investing in this area, and you can see yearly this number of the publications in this biosensor rapidly exponentially is increased. Why? Because nowadays people are very much interested in this area. If you see in the SARS-CoV-2 situation time, many people are trying to develop so many devices, right, for diagnose this SARS-CoV-2 virus. So this is nothing but some biosensor. This is just all our biosensor device. Yeah, we can develop. And you can see there is so many techniques. People are developing sometimes the calorimetric technique, like other like mass biosensor, other things. But electrochemical, you can see the black bar. The electrochemical technique is actually people are focusing more. This is actually very interesting area where people are focusing. Okay. See now. Now, what is the challenges in this diagnosis area? So let's find out the challenges. So first point, for the point of care, we have to think about some quick detections. This is a very important point for point of care biosensor device. Why I'm saying quick? Because sometimes, for the detections of disease, we have to wait for not only few hours, for few days also. So we send the samples to the diagnostic center. So they will go for the pre-processing. They have to wait for a long time for the reaction. But it is not useful for point of care. So each point of care case, the first important thing is should be quick. Just drop. If we can find the solution immediately, that will be very good for point of care. Also, sometime very emergency time, we should know the result very immediately. We know we should have the data, right? But if you wait for a few days, then it is very difficult to send the patient for some. We cannot make some conclusion for diagnosis or for some surgery or something like this. So we should have the quick decision making some device. Another point is on-site detection. As I said, if some emergency time, maybe immediately on the patient, near the patient, we have to get the value, we get the data for this any kind of disease if your C has, or if we need some information from the patient sample, so it should be on-site. And third thing is the ultra sensitive. So what is the meaning of the ultra sensitive? Means the sensor should be very, very sensitive. If it is not, maybe patients has this disease, right? But as your device is not sensitive, it will show negative result. But the disease already there. You don't know because your sensor is not that much sensitive. So we will develop such a device so that at very low level disease marker also we can detect by using that device. That is called ultra sensitive detection. But what is the answer right now? In the market, this kind of device like quick, on-site, ultra sensitive is very rarely available, almost no. So as I said, only like pregnancy test kit, glucometer, this is very, very, people are nowadays using, that is very, very common. But like cancer and any other typical disease case, it is not available. That's why it is very interesting. It is very, very interesting to find out some detection technique, some new device that can detect the disease by using these three steps: quick step, on-site, and ultra-sensitive way. So these three challenges we have to face, we have to overcome when we will develop some point of care nanobio sensor. Clear, guys?
Yes, sir.
It's very interesting. So I'm giving you the motivation. If you see this general idea, if you have in your mind, then you can use this all this fundamental knowledge for any kind of biosensor. So that's why I will request all of you, don't miss any first few classes. Because first few classes I will teach you so many keywords that is very, very fundamental, and it will be useful for all of you. And you can think about some new idea based on this fundamental knowledge. If you don't know what is this ultra sensitivity, what is this specificity, and what is the biosensor, what is the bioreceptor, what is the transducer, then each step you will face some problem, right? And first few classes I will go a little slow so that you can understand each point. Then you just ask questions, keep asking many questions so that you can clear your basic things. Okay. So this is the interesting topic I taught you today. So Wednesday I will go for some new technique, that is lab on a chip technique. So that is very vast, very broad area. So I will cover on Wednesday. But I will share this slide today. By tomorrow I will share this slide. Try to read. I will share also few books, some ebooks also I will share. I also published few books also in this area, and personally I also wrote some books here in this area. I published some papers also in this area. So I will all the kinds of study material will be available in the team. There is a channel, class material for point of care. So you can find all the class material in this channel. Okay, and try to understand, and you can ask the questions during the class also. We can discuss.
Excuse me, sir.
Tell me.
Any particular book we should follow, sir?
No, as I said, this is very interdisciplinary. No need to follow any particular book. I will share you many books, but I will prefer read some very recent topic that is available in the online. Many journals you can read. But if you need some guidance, how we can start the journal, how we can read the journal, that thing I will guide you one day. So one class I will take where I will guide you how to search journal, how to read papers. That I will guide you one day. Okay, clear?
Hello, sir.
Tell me.
Sir, like I have one doubt. Like, as you are going regarding the health system, sir, if the biosensor you are creating, can it be a means reusable? Because if we, I'm not talking about any healthcare, but if it is from other of that, like you are going for food security or another, if you are
Huh.
using one biosensor and means it is for one time only, then it will be a very costly process to detect number of. So, is there any uh, what to handy biosensor which can be reusable, or it so any research is going in the direction?
Good question. So your name, what is your name? Bravis Delta, right?
Sir, Bhavesh Datla.
Bravis Delta. See, in the biosensor, I will teach you some keywords. One is reusability, one is reproducibility, ultrasensitivity, specificity, selectivity. This kind of many topic will come slowly. When I will teach you some fundamental sensor design and device, that time I will cover this one. Is this sensor reusable or not? So some sensor we can reuse, some sensor we cannot. Like we are sometimes developing, we are using antibody. So antibody can bind easily with the antigen. There is a very strong binding. Sometimes we cannot remove them. So what do we have to do? We have to throw them just one time. But how we can make it cost effective? That technique I will teach you. Sometimes, yes, we cannot reuse, but we can make them cost effective sensor device. Then only we can tell you, yeah, it is for easily, it is applicable for point of care, it is affordable, or developing countries they can use. Some biosensor really is useful for this, I mean, that you said, right? Reusability, that technique we can use. Means we can wash it, we can reuse again. That possible. So some case possible, some case not. So that all the cases I will cover one by one. Okay, that you will learn.
Okay, sir.
But that is good point. You asked me. That is good point.
Hello, sir.
Tell me.
Sir, sir, I just have a follow-up question to what was asked before. The question that the doubt which I have is when the research is being done on biosensors, trying to make new ones, is research, does the research also is focused on, how to dispose biosensors if they are, they are like a one-time use, like pregnancy test. Like you can use it only once and you have to throw it. But usually, is any research being done to find out that how can we, because there is a lot of global warming, pollution, and a lot of stuff. So there is a lot of medical waste generated. So is there any research work going towards that side? How to buy? Is there any research work regarding biodegradable biosensors, something like that? Just curious.
Right. Your question is nice. So that kind of question should come in this class. So like this way, see that's why I'm just throwing some ideas. See now so many questions coming. Like this way, only we can go for research. Yeah, people are doing some biodegradable biosensor. So like paper based, they are using some chemical that is not hazardous for environment. Some environmental friendly chemical we are using. Also some environmental friendly like paper strip we are using, so that just after throwing it can be, I mean, it is biodegradable. No, I mean, there is no point that it can hamper our environment. So something like this people are doing on this area. It's really interesting topic people doing. But still we can think about, sometimes we are developing some glucometer, like glucose test meter, but there is some component we are using like some metal based material or something, like if you use some mercury or something like this, maybe that is not much environmental friendly, then don't use them. Just try to use some material like gold or some iron base or some carbon base. That is environmental friendly or biodegradable. So that point I will come also. But there is so many research still going on.
Okay, sir. Thank you.
But one by one I will cover, and I will arrange some classes where we will discuss freely like this point. We will point out, and together we will solve all the problems. So just note down all the questions you are asking me. So one day I will arrange a class like mutual discussion with me and all of you. That day we will try to solve, and we will search online. Or you can, this kind of question you can search online also. You will get many publication also. And if you don't understand, you can send me that paper. Just say this kind, there is some issue, I mean the topic that is not familiar with you, so please discuss with me, so I can discuss it. Okay.
Sir, have you shared the YouTube link, sir?
Yeah, I sent a YouTube link, but I will share. But next class also I will try to, maybe in my computer there is some option I maybe somehow it's muted, or somehow I didn't turn on. But next class definitely I will turn on the sound option. But I will share. I already shared in the chat box.
Sir, it is not sent yet, I think, sir.
Really?
Yes, sir. Like that arrow
Okay.
on.
Okay. So now you can see. Right? It is shared, right? Okay.
Yes, sir.
Yes, sir, it is shared.
So, but don't worry, I will share the slides also with this link. I will share the slides. And next class also, I will turn on the sound option. Don't worry. This is Wednesday from 3 to 5. So please follow the time. I will be always on time there. Okay. Okay, guys.
Okay, sir.
Okay, yes, sir.
Yes. Thank you, sir.
Okay,
Okay.
thank you,
So
sir.
everything, I think my
So thank you, sir.